Okay, guys, now we are going to look at working with those exponential functions and what exactly they do. So the first thing you need to do is make sure you're on the page, okay, that has the plus sign on it. They look really, really similar, okay? So make sure you're on the plus sign one. And we're going to talk about this. That plus means exponential growth, okay? That's our exponential growth. As a reminder, A is our initial value. I feel like the more we write this, the more we're going to start to remember those terms, okay? T is generally the time. Y is still the final value or the final amount, final total value or amount. I like to say all those terms because it really depends on what we're dealing with, what it's going to be. Now, R is a little bit different. So you'll notice it has the 1 plus here. It just doesn't have the B. This whole thing is our B value. But R is the rate of change. We know that word from slope. It's the rate of change. What is that percentage of change? Okay, and all these are going to be positive. Okay, it's going to be up. All right. So don't get too overwhelmed. There's a lot of writing going on here, but it's a lot of word problems. And we're going to do some practice on them too. Okay. So let's look at this. Interpret the parameters of an equation. So big fancy words. The number of users in millions that belong to a social networking site can be represented by y equals 1.5 times 1.4 to the t, where t is the number of years after 2013. Interpret the parameters of the equation and make a prediction about the future number of users. Okay. So on this one, it just wants us to talk about what the parameters are to make a prediction. Okay. So what is our A value here? We can talk about what our A value is. What's our initial value? It is 1.5. But what does that 1.5 talk about? The millions of users. Okay, so that's the number of users in the millions. Okay, or millions of users, however you want to write that. And then our next one is that 1.4. Okay. But on the point 4, we just want to talk about our R. What is our rate on this? What is the rate? The rate is the difference from 1. So it would be 0.40, okay? And it is the rate of increase because it's greater than 1. Okay? So it was 1 plus 0.40. And to find it, you could also do 140 minus 1, which is your B minus 1. So that's what that one is looking for there. Okay, so that one was kind of simple. Our next one is exponential growth. So we're actually going to do a problem now. So we know how to pull out the parameters and read it and interpret it. So now we are going to use it. The prize for a radio station contest begins with a $100 gift card. Sorry, begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call or the prize increases by 2.5% for the next day. So write an equation to represent the amount of the gift card in dollars after T days with no winners. So we need our Y equals, okay, so I'm going to go ahead and say we need our Y equals our initial value. What is the initial value that we're looking at in here? It's that $100 gift card. Okay, that's our A value. And it increases by 2.5% the next day. So really 15 minutes has nothing to do with it. It's just part of the contest. Okay. So it's going to increase by 2.5%. So that means we're going to have 1 plus 2.5%. So to change a percent to a decimal, okay, to change a percent to a decimal, we divide by 100. So that 2.5 divided by 100 is 0.025. It's really important you do that. 0.025. It's like 2 cents. Okay. It's 2.5 cents of a dollar. Okay. To the T value. Okay. So that's part of our function. The T is part of our equation. Okay. Some people also like to write that already combined. So you might see it written like this, like we did in the first problem, 100, right? Times 1.0. So they do that extra math right there. You'll see that written out like that a lot. Okay, just remember they've already added it if it's greater than 1. So now let's go down here. How much will the gift card be worth if no one wins after 10 days? So we're going to find the value for 10 days. So is that 10 going to be, what are we going to plug that in for? That's what you need to think about. What are you going to plug that 10 in for? It's going to be the t. So when t equals 10. So all we're going to do is plug it into the calculator. That's it. Y equals 100, right? Times 1.025 to the 10th. And how much money is that, my friends? How much money would the big winner get on the next day? Should have gotten 128.01. 128.01. And something I didn't do, let me pause it for a second. I wanted to bring the calculator up just to, I apologize, to show you guys how to enter those equations in the calculator. So you would do, on the regular calculate screen, you would do 100 times 1.025, close parentheses, you would use the caret key and the, the caret key and the variable key if you're graphing it. We're going to just plug in the 10 right there and solve. So you use the caret key to get up there. Okay. And that is it. That is your answer. So let's go on to the next page. So we just did growth. What do you, oops, we're still doing growth because now we're talking about interest rate, okay? And interest rate is our PERT. And y'all might have done that back in the day. Still written the same way. You have your principal amount, but you have this E value. And this E value is actually a key on the calculator that we do. And we don't always do this in class, but I do think this is a good question to go on ahead and go over. So you're just going to plug in the information. Let's look at those, the information. Maria's parents invested $14,000 at 4.2% per year, compounded continuously. How much money will there be in the account after 10 years? So let's go on ahead and write our equation. The amount will be your principal amount, your initial amount, which was $14,000. I wish. Whew. Times the E value. This is in the calculator. This is a key in the calculator. We will talk about that in a second. To the RT. So the interest rate goes up here. The interest rate would be 4.2%. Okay. So E to the 4.2% per year. And don't forget, guys, we do have to convert that over. And that would be 2 places over, divide by 100, which would be 0.042. So 0.042 times the time, which is 10 years. And you will enter that in the calculator. So let's bring up our calculator. You do have to have a graphing calculator for this one. So we're going to enter our $14,000. For our E, it's going to be the second LN button right here. It's the second LN button, has a little E to the X up there. So it's going to type it in for you. And then you're going to put 0.042 times 10. You hit enter, and that's 21,000. Dude, I wish my parents, 21,307. Isn't that what it was? And 46 cents. So good amount right there. So that's a special function. So how do you get to the E value right here? To get to the E key in the calculator, you're going to do second and the LN key. Second LN key. Next one, after growth, we are going to talk about decay, of course. So this is going to be our exponential decay side. Okay, we're going to talk about our decay. And again, y'all should know all this by now. I keep on making y'all list it because I'm hoping it'll like stick. A is our initial value. Okay. Y is the total or the final value or the final amount. Okay, so it's going to be what we get in the end. All right. T is our what again, guys? Time. And R again, okay, R is the rate of change. So R is the rate of change. And this little information below it, expressed decimal, this is where we said that it is between 0 and 1. It's between 0 and 1, okay? And the big key right here is this one is your minus. This is your minus. This is your subtract, okay? So it's going to be smaller. Okay, it's going to be smaller than 1. It's going to be change, okay? All right, so on number 4, we are just going to determine again the A value and the R value of the equation, okay? So the rate and the initial value. The percentage of area in the continental United States not covered by a cell phone service provider can be represented by y equals 0.015 times 0.45 to the t, where t is the number of years after 2012. Interpret the parameters of the equation and make a prediction about future coverage by the service provider. We're actually not going to make the prediction, okay? So A equals, just showing you what a problem would be like. A is our initial value, which would be what? What is A? A is that initial value right there, the 0.15. And what exactly is it talking about? It is the area with no coverage, okay? It is the area not covered by cell phone coverage, like my dad's living room. Yeah, like my dad's living room on Lake Conroe. Now, what is our R? Okay, this one's a little bit different. There's no 1 plus there. We can't easily interpret it. Our rate is actually the difference from 1. So our rate is actually 0.55. So it is 1 minus that 45 cents, which is 55 cents. So remember, it is always the difference from 1. So it's easier to see it on a growth. It's way easier to see it on a growth because we actually see that over a dollar. You have to say the difference. The rate is the difference from 1. So that's really important there. Okay. And then we're going to do it into a problem and apply it to the math. Then we have a couple more examples going on. All right. A fully inflated child's raft for a pool is losing 6.6% of its air every day. Talk about real world. We all have one of those pools in our backyards that last forever. You just don't want to go empty it. It has all the grass in it, and it's just like slowly getting smaller. The raft originally contained 4,500 cubic inches of air. Write an equation to represent the loss of air. So you have y equals A. What is our initial value? 4,500 times it's losing. So that's going to be a subtract, the 6.6%, and I have to convert that to a decimal. So that's 1 minus 0.066 to the t value. Now, here's our or part of it right here. You might see it written as already subtracted, this part already being subtracted. So that would look like 4,500 times 1 minus 0.066 is 0.934 to the t value. I'm going to use this one just because it's less to write, honestly, and I know it's a decrease, so I'm just going to use that one. So let's go to our next problem. And estimate the amount of air in the raft after 7 days. So we're looking for where t equals 7. Where does t equal 7? Okay. So I'm going to come down here and I'm going to do y equals, my initial amount doesn't change, my rate does not change, to the 7. So I need to go plug that in the calculator. Give y'all a second to plug it in the calculator. And you should get 2790.23 inches cubed. That's cubic inches. And that would be your answer. Okay. Our last one, I really like example 6 and example 7 because it's asking y'all to just interpret the information. Tell me what this means in here. And I do think it brings out a nice, I think it brings out a nice use and reminder of what some of this stuff So we have the equation f of x equals 1800 times 1.5 to the x. So it wants us to identify these words: the initial amount, the final amount, the time evaluated, the growth factor, and the growth rate. So the growth rate's just a little bit different, like where you're doing all the math here. So it's going to give us the math. So the 1800 is the, and I hope you all got this, the initial value. The 1.5 is the growth factor. It's the factor that we're multiplying by because 0.5 is the growth rate. And it's really important to recognize that. The difference from one is the rate that it's growing by, the rate that it's changing. Okay, I'll do a different color. The f of x is this right here, which would be our y value. So that's going to be our final amount. And then the x value is going to be the time evaluated. So how long were we waiting, or how long was it going on, and generally that's what it is in all these problems. So for number 7, normally I'd like y'all to do it on your own. So if you pause right here and take a second to do it, and then we will show the answers. Okay. 978 is our initial value, the initial amount. 0.97 is the decay factor. It is the decay factor. 0.03 is the decay rate. F of x again is our y value, which is our final amount or total or value, whatever we're using. And x again is our time that we're evaluating that function for.